Hey students, this is lesson 2.2, solving two-step equations. The objective here is that you're going to learn how to solve two-step equations in one variable. All right, let's review a couple things. I'm going to pause here. You can see if you know these answers and check back. All right, so we're going to learn how to do two-step equations. Here's a quick review of what you might want to do. The order of operations is important because when you work backwards to solve an equation, you want to reverse the order of operations. So keep that in mind. So notice in this one that in the equation, you would first multiply 2 times x and then add 3 to get 15. When you're solving this, you are first going to want to undo this operation, the last operation you did, and then undo this multiplication second. And the way you undo it is the undoing operation is just the inverse operation, the opposite. Like if it's addition, then you're going to subtract. If it's multiplication, then you're going to divide, and so on. So go ahead and circle the first operation you would do in solving each equation, then write the inverse operation you would use to undo that. All right, so let's use that idea here. When we solve this two-step equation, we're going to do 2 things. There's multiplication right here, and that comes first, and then there is addition right here. That comes second. So when we go backwards, we are going to undo those by first subtracting 11. And I'm going to subtract 11 from both sides. That's the subtraction property, the equality at work. Now, I'm going to do this just a little different the first time so you can be familiar with the way you see it in the notes. But basically, I want to subtract 11 from 2x minus 11 and subtract 11 from 51. So that's going to look like that. That's the subtraction property of equality at work. Then I'm just going to simplify that, and that gives me 2x plus 0. And I'm not going to write plus 0 because I know that addition has the identity of 0, and it's going to equal just 2x. 51 minus 11 is 40. And then, and we'll just say that's simplifying. And then the way you undo multiplication is by dividing. So I'm going to divide both sides by 2, and I get x equals 20 for my answer. And what I did there, right where I divided by 2, that's the division property of equality. All right, so you go ahead and try that. Just a reminder here, you should always check your equation. So let's say we think t equals 16, then you should just check that and make sure if we substitute 16 for t, that it's true. And 16 divided by 2 is 8, and 8 minus 3 is 5. So it is true. That makes us happy. All right, using an equation as a model. So a train is 100 miles away from a station. It is approaching the station at 40 miles per hour. How long will it take the train to arrive? This is kind of a 4-step plan for solving equations. You want to think about the problem. Then you want to think about what you know about the problem, what you need about the problem, and then you make a plan. Okay? What I'm thinking when I see miles and times and stuff like that is I'm thinking distance equals rate times time. All right? And in this problem, 100 is a distance. I know that. My distance is 100. And 40 miles per hour, that's a rate. My rate is 40. I need a time, and that's my hours. That's what I'm looking for. And my plan is I'm just going to substitute what I know into my formula for distance. So substitute in values. So, and that's going to look like that since the distance is 100. I'm going to put that where the d is. And since my rate is 40, I'm going to put that where the r is. And then multiply that by time. And then now I see I have an equation that has multiplication. So when I'm doing that, I'm going to divide 100 by 40, and that's equal to 2.5. So I'm going to say it takes 2.5 hours here. All right, I'm going to let you try that. All right, problem 3, solving with 2 terms in the numerator. No difference here. We just need to identify the operations in the order that they're needing to be done, and then work backwards to the opposite of the order of operation and the inverse operation. So notice that because of this divide sign, that's a grouping symbol. We have to add 5 first, and then we divide by 6. So when I undo this, I want to undo the divide by 6 first. So my first step is going to be multiply this by 6. So I multiply 6 times that, and 15 times 6 over here. Now when you multiply by 6 and then divide by 6, those just equal 1 as a fraction. Remember, this is grouped. And now I have just x plus 5 equals 15 times 6, which is 90. Then my second step is just to subtract 5 to undo that. And that's equal 5. And you should check that, make sure it's true by substituting it back into the original equation. And 90 divided by 6, make sure that equals 15. And I think it does. All right, go ahead and see if you can identify the properties used to do this. Fill in the missing things. One thing you might notice is that in the examples, they're working horizontally right here, and when you see me do my examples, I work vertically. Like when I subtracted 5, I did it underneath here. You can choose whatever you like better, but I like to work vertically when I'm solving equations. All right, we're going to use deductive reasoning here to solve this. And what deductive reasoning is to justify your steps logically so that there's only one possible conclusion. And the way we're going to do that is just say what properties we're using, because their properties are like laws. So we're thinking about this, and the first thing I'm thinking is I want to subtract 10 from both sides. And the reason I can do that is because there's a subtraction property of equality. All right, and now I'm going to simplify that. That is 0 plus 2x equals 10. Now, we might skip this normally, that 0 plus 2x part, but I'm going to just write it down just to show that there is a logical reason why it works. So we're simplifying that. Well, that's just equal to 2x, and that's because of the addition identity property of addition, or I'll just call it the addition identity. All right. And then we want to divide by 2 for our next step, and that's the division property of equality. And then I'm going to simplify that. 2 divided by 2 is 1x. Now I'm adding some steps you normally wouldn't do, but I'm really trying to prove this logically. So 2 divided by 2 is 1, right? And I just simplified there. And then the last step, I'm going to say 1 times x is x, and that's because of the multiplication property of equality. Now from now on, I'm okay with you just skipping the, oh, that was wrong, sorry, I said that wrong. That's a multiplication identity. I'm going to let you skip the identity things if you want, but I'm going to let you try that now. See if you can justify the reasons here. Oh, I want to change a couple things for you. Instead of saying multiplying each side by 3, let's say multiplication property of equality there. And instead of adding 5, we're going to say the addition property of equality. Use those instead. All right, how'd you do? Say, I noticed in your handout, we're missing this last problem here, the lesson check. So what I would ask that you do is just pause it now and answer this question, and go ahead and write that answer into your packet, and that's where we will start the next time I see you in class.